What's up everyone, welcome back, Patrick here, and in this video what we're going to do is graph the function f of x equals 3, the square root of 12 minus x over 2 plus 4. So first thing to notice in this particular example, the parent function we're dealing with is f of x equals the square root of x. So we're going to be transforming it and then graphing it. Now, what's the first step in the process? As usual, we want to try to take our function and put it in that general transformation format, which is y equals a f bracket k bracket x minus d, close the two brackets, and then we have the plus c at the end. Now, in our particular function, notice that the a value is very easy to get. It's just a 3 in front. And then the c value is easy to get. It's just the 4 at the end. What's going to be tricky is getting the k and the d value inside the square root. We have to manipulate that part, that expression a bit, in order to get it in that same form. So first thing I'm going to do actually is the 2 at the bottom, I'm going to take that out, so it's like we're taking out a 1 over 2, and then what's left in brackets, well, the numerator, the 12 minus x. But notice that in the general transformation format, it's x minus d, and in our format, we have 12 minus x. So what I'm going to do is switch those two around, and it's going to end up being negative x plus 12. But then there's still a negative in front of the x, so I'm actually going to factor out the negative, put it with the 1/2, so we just have a negative 1/2 factored out, and now we end up having x minus 12 left in the bracket. And now it's easy to get the remaining transformation values. So notice that the k value is going to be negative 1/2, and then the d value is going to be positive 12. And so from here, we can now transform that parent function, the square root of x. Now the square root of x, what's the table of values we usually use? 0 and 0, 1 and 1, 4 and 2, 9 and 3. So what we got to do is take those points, put them through the transformation formula. Now remember, what is the transformation formula? Well, for the x values, it's x over k plus d. For the y values, it's ay plus c. So we got to take our transformation values and put it in that formula. So when we do that, we end up with x over the k value of negative 1/2, which actually simplifies to negative 2x, right? It's like x over 1 divided by negative 1/2, which when we're dividing by a fraction, we flip that fraction, so it ends up being x over 1 times negative 2 over 1, which gives us that negative 2x. And then we're adding the d value, which would end up being positive 12. So that's the formula for the x values, negative 2x plus 12. For the y values, the a value is 3, the c value is 4, so it end up being 3y plus 4. So now what we do is we take all of our x values from the parent table and we put them through that formula for the x values, the negative 2x plus 12. So for example, if we take that x value of 0, negative 2 times 0 plus 12 would give us 12. What if we take that x value of 1, negative 2 times 1 plus 12 would give us 10, and then so on and so on. And then we do the same thing with the y values. So taking that first y value of 0, 3 times 0 plus 4 would give us 4. Taking that next y value of 1, 3 times 1 plus 4 would give us 7, and so on for the other two y values. And now at this point we have a complete table for that new transform function. So now all we got to do is take those points, plot them on the graph, and then join the points. And remember, the 0 and 0, that gets transformed to 12 and 4. So that ends up being the vertex, quote unquote, of the square root function. And so the arrow is going to be on the other end. And that ends up being the final graph for the function.